Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 9 applied students who are looking for a little more help as they study for the EQAO. It's video number 5. What we're doing in these videos is looking at the questions that were released as last year's EQAO questions. They can be found on this website, and again, they're multiple choice or open response questions. And so what I'm asking you to do is, as you're listening to these videos, you should be following along with the questions from the website. Hopefully you've tried them on your own. And feel free to post in the comment section any questions or requests to do other questions or more on a particular topic. Okay, let's look at the next question. So we're on to question 13. It says a plumber charges an initial fee of $50 and an additional $25 per hour. Which graph represents this relationship? So I always like to start with initial fee. So I know that the initial fee is $50. So I'm going to look at all the graphs I have and see which ones start at $50. Well, this one starts at 0, so I'm going to cross it off. This one starts at 0, so I'm going to cross it off. This one starts at 50, so I like it so far. This one starts at 25, so I'm going to cross it off. Well, that was easy. I'm just going to make sure that the rest is true as well, so I didn't miss anything. Charges $25 an hour. So if he's there for 1 hour, then I would have to pay him $25 for 1 hour plus his $50 initial fee. That's a total of $75 if I see him for 1 hour. And if you look at the graph, 1 hour is $75. So this is definitely the answer, number C. Pretty good question. Let's go on. A snowstorm lasts for 7 hours. Data is recorded for the depth of snow for the first 5 hours. Which graph best models the depth of snow during the 5 hours? So I know that I've certainly given you enough examples where if you get a table of values, you calculate first differences. So I'm adding 1. I'm adding 1 plus 1 plus 1. So the first differences for time are constant at plus 1. Now, depth of snow, plus 3, plus 3, plus 3, plus 3, and plus 3. So this is also constant. If they're both constant, I know it's a linear relationship. So I'm going to cross off A and cross off B. Now, both of these are linear. They both show an increase. So the other piece of information that's important when you look at a table of values is, can you find the starting value? The starting value is always when you see a 0 on the left. So a 0 on the left tells me that this relationship starts at 5. Now, graph C doesn't start at 5, it starts at 0. That's not it. Here, this could certainly be 5. So it's the only linear relationship that is not direct variation. So do you remember direct variation and indirect variation? Sure you do. Let's review really quickly by looking at these two graphs. Direct variation is when a graph passes through 0, 0. So you would have to see 0, 0 on the table of values, and we definitely don't have that. Indirect variation is when the graph starts either above 0 or sometimes below it. This graph starts above 0, and I know that it was supposed to because that's what that point tells me. So again, the answer is D. Let's move on. In which of the following patterns is there a linear relationship between the number of shaded squares and the term number? So here's what they want you to do. They want you to create a table of values. In the last question, they gave me the table of values, and we checked if it was linear. Now they want us to create our own table of values and see if it's linear. So I need to compare the number of shaded squares with the term number. And it doesn't really matter which one goes on the left or the right, but when I think about it, I think I'm going to put term number on the left. It seems more likely that number of squares depends on the term number. And so therefore, term number is supposed to be on the left, where x usually goes. So for A, term number 1 has 1 square. Term number 2 has 3 squares. Term number 3 has 5 squares. Term number 4 has 7 squares. Is this a linear relationship? Plus 1, plus 1, plus 1, plus 2, plus 2, plus 2. Oh, that's already a linear relationship, so I'm pretty sure my answer is A. Now, just because we have time to explore it, I'm going to look at another one anyway, just to be sure you understand the concept. So let's look at C. So C, again, I need to compare the term number to the number of squares. And so I'm just going to count and fill in my little table of values. Term number 1 has 1 square. Term number 2 has 4 squares. Term number 3 has 8 squares. Term number 4 has 12 squares. So let's look at the pattern. Plus 1, plus 1, plus 1, plus 3, plus 4, plus 5. That's not linear. So do you understand what you're supposed to do is make a table of values. We all are pretty good at checking first differences. We know that constant first differences are linear. So sometimes all you have to do is make a little table of values and check first differences. Okay, let's look at the next question. Oh, look, a table of values. An online music store provides music that members can download. The store charges a membership fee and a cost per song. The chart below shows the relationship between total cost and the number of songs downloaded. Which of the following is not true? So I'm going to start by doing what we always do if we see a table of values. Let's find the first differences. Add 3, add 3. So excellent. So far, it's linear. So which of the following is not true? Okay, phew. It is nonlinear. Is that true? That's false. And that's the one I'm looking for because it said which one is not true. But just in case, let's look at the rest. It has an initial cost. Well, the initial cost would be if I had 0 in my table. And since I went up by 10, let's go backwards by 10. And if I go backwards by 10, I'm going to go backwards by 3, and that gives me a starting value right here. So it definitely has a starting value or an initial cost. Does it have a constant rate of change? Yep, we checked that for sure. Can it be represented by a straight line? Well, yes, if it's a constant rate of change, it must be a straight line. So the thing that's not true is this, because it is linear. Therefore, saying it is not linear is a lie. Okay? I hate questions that are negative questions, but I don't write the question, so what can you do? Moving on. At her fitness club, Joanne is charged $15 per month. The total cost for 12 months is $270. Is the relationship between total cost and number of months a direct or partial variation, and what is the initial fee? So first of all, go back to this initial group of information and check the math. She's charged $15 per month for 12 months. So if she has to pay $15 every month over a period of 12 months, then she paid $180. But we're told that she actually pays $270. So actual pay is $270. The difference between this number and this number must be her initial fee, right? We know that every month she's paying them $15, but that only accounts for $180. So the difference between what she actually gave them and what she gave them over 12 months is the initial fee. So if I do 270, subtract 180, the difference is $90. So this is what must have happened. She walked into the gym and they said hello, and she said, hello, my name is Joanne. What do you charge? And they said, well, we charge you $15 per month. That's pretty cheap. However, there is an initial setup cost of $90. And that initial cost includes your photo ID, your locker, towels, a personal trainer, who knows. So this $90 got paid once, and then every month she paid $15 more. So is that clear as to why these two numbers are different? Right? $180 is what's taken care of by $15 for 12 months, and the difference therefore is what she must have paid up front. So now you can tell that only one of these has $90, and that's good, but let's make sure we again review direct variation versus partial variation. For example, no one on any planet should be circling this one, because direct variation, by definition, has an initial fee of 0. So if you answered B, if anyone answered B, they really don't understand direct variation. Because again, direct variation must start at 0, or else it's simply not direct variation. Now here we didn't start at 0, we started at 90. So that's partial variation, started at 90, so the answer must be D. Okay, let's move on. Question number 18. The total cost for printing a classified newspaper, a classified advertisement in a local newspaper, is a $30 fee plus 10 cents per word. So that's kind of like the gym question we just did. There is a $30 upfront fee. Then you also have to pay 10 cents for every word. So in the last question, there was a $90 upfront fee, and then you had to pay $15 every month. Same idea, different question. Which equation below models the relationship where C is the total cost and W is the number of words? Now, make sure you understand $30 is the fee. A fee, an initial fee, a flat rate. This only happens once. You don't pay this every word, or else, no one would put in advertisements. You pay $30 once. So when you look at the equations, look for equations where you only pay $30 once. For example, B says you pay $30 every word. Boy, that's definitely not the right answer. A says you pay 30 cents every word. Well, that's not what we were told, is it? 30 cents every word? We weren't told that. Cross that off. $30 starting fee. I like C. $30 starting fee. I like D. So let's look at what's different between C and D. This says $10 per word. Ouch. This says 10 cents per word. So it's got to be D. So hopefully a pretty easy question, right? Just don't rush through it. Look carefully and use your logic. Okay, so I'm going to stop this video because we're running out of time. It's question 18, so the next video will start with question 19, and I'll see you there.